استنى احنا بس ندرس الويز وين ندرس من وين ندرسها.
هلا ببعث لكم البوكلت.
هي
تمام.
كم ساعة الحصة؟
الساعة 12 و10.
لا
No, we did this.
أستاذ ما بس قد الساعة، كم من ساعة الحصة؟
اليوم الكلاس
ساعة؟
إذا فيش وراكم شيء خلينا ناخذ ساعة ونص نخلص شوي نقطع شوي.
عندنا ايس تي بعد هاي
كويس. طيب فاين. خليكم بس معي شوي. Guys, هلا احنا we talked about the reflection in light صح؟ وحكينا عن ال properties of reflection of light in mirror، حكينا عن properties of the image. هلا when the sound is incident on a big surface, part of the sound energy is being what? Reflected, with the reflected sound wave heard after silence. And to distinguish this echo, we need a period between 0.1 second, around 0.1 second, between outgoing sound and reflected sound. In order to hear the echo, this is will be regularly asked about it. The echo sound is used to survey the depth of what? The depth and nature of the seabed. Yani, for example, if I want to investigate or want to know the depth of the sea, this is the depth. Okay. Here, let's say this is a ship, whatever. Inshallah, عني إني فنان في الرسم. This will, the ship here will send waves. These waves will be reflected back again. Okay, will be reflected back. How can we measure this depth? By knowing the speed of sound in a particular medium, which is water here, right? Which is what here is water, and the sound here is, or the sound here travels in water, Now we will measure the time. We will measure the time of echo, and the time between the moment where when the waves are sent to the moment where the waves are received again. We calculate the distance using this. 2 times distance equals speed times time. You know why I multiplied by 2? Because you guys, yes, the path, the length of the path of the waves, d, this is d, right? And this is what, when it returns back again, it's d. So the total distance is 2d, which is equivalent to speed times time. And this is, you know, I think you are familiar with this equation. Distance equals, or total distance equals speed times time. Okay, speed times what? Time. I can find the depth of any sea or any ocean using this way, Secondly, I can use also the concept of echo to measure the speed of sound, خليكم بس معي شوي guys. صباح الخير نسين، كيف حالك؟ بس بدي تخبري أهل هدول الطلاب إنهم ما حضروا معي اليوم. زينة أعتقد زينة نادر اللي هي حرز الله، ولا مش حرز الله؟
على فكرة أستاذ أنا هون.
لا زينة حرز الله اللي ما حضرت.
زينة حرز الله ما حضرت. طيب ماشي، حقكم علي. مين عندنا؟ شهد، لا هاي شهد سوري، سما، وعندكم ميرا، ومين كمان؟ أحمد عامل دروب، فاطمة وقمر، سلمى، وهج،
فرح موجودة. بسأل موجودة.
هم زين حفظ الله، هدول 5 ما حضروا. أحمد عامل دروب، تمام. عندنا كمان مين؟ سلمى، قمر. والله مش نسرين تحكي معها اليوم بعد إذنك. طيب نرجع. Okay, guys. I want to measure the speed of sound using the concept of the echo. I have to bring two pair of clapper boards, measuring tape, 2 or 3 stopwatches or stop clocks. Let's say this is a wall. Okay, this wall around should be more than 50 meters away from the source of sound. This is the source of sound. Okay, it could be clappers or whatever. And at the moment when the sound is produced, we started the stopwatch. Okay, when we hear the first echo, we stop the stopwatch. Okay, clear? So accordingly, I will measure the distance from a tall building, around 100 meters if it's possible, snap the clapper boards together outside in front of the building and record the time it takes for the echo to return. Repeat the experiment, guys. Definitely we have to repeat the experiment in order to find the average. Calculate the speed of sound. Similar way, I have to use the speed equals 2 times distance over time. Why? Because you know in echo the sound is moving first of all this distance and reflected back again this distance. So in this way we can calculate what the speed of sound. Another way to measure the speed of sound using 2 microphones like this, and these 2 microphones are connected to what? To say a scale meter or timer, whatever. Sorry, timer. I meant timer. And I have to measure first of all the distance between these microphones. Okay, when the first mic detects the sound, the timer starts. When the second microphone detects the sound, the timer stops. So we can find the speed of sound using a measured distance over the timer on our computer or on the timer. Is that clear, guys? Any question about that?
No.
No, sir, no.
Great. Now look to this question. This is an old past paper question, guys. In an experiment to measure the speed of sound in steel, a steel pipe of length 200 meters is stuck at one end with hammer. A microphone at the other end of the pipe is connected to an accurate timer. The timer records delay. This is an important 0.544 seconds between arrival of the sound transmitted by the steel pipe and the sound transmitted by air in the pipe. The speed of sound is given. Calculate the speed of sound in steel. Calculate the speed of sound in steel. Let's say this is the steel pipe. Here, this is the hammer. Okay, here there is a microphone. Inshallah. This microphone is connected to what? To a timer. Okay, guys, here we have sound travels in steel. We have sound travel where? In air. Yani the microphone will be received by 2 sounds. Sound travels in steel, then the sound travel in air, because you know that in the speed of sound in steel is larger than the speed of sound where? In air. Clear? This is why there is a delay. This is why the microphone, this is why did the microphone detect delay in the sound, because we have two sounds travel, one through the steel and the other through the air. The difference between these two sounds, the difference between the speeds of the sound in these two media, sorry, will cause a delay. Okay. هلا we are asked about speed of sound where in steel. هلا speed of sound in steel equals what? Distance over time. The distance is given 200, but we are asked about, we have to find first of all what? Time. We have to find what? The time. What I have to do, طلع معي هون. We are given that a delay 0.544 seconds. Pay attention guys here. Pay attention. زين خليكي معي. شاهد خليكي معي. هلا how we will consider a delay? What is meant by this delay? A delay means that time for the sound to travel in air minus the time for the sound to travel in steel equals 0.544 seconds. This is the delay. Okay, guys? So in order to find the time for the sound to travel in steel, I have to find the time for the sound to travel in air. Time travel in air equals distance over speed. Distance 200 over speed, which is 300, I think, 343. Does anyone have a calculator, guys?
أنا.
يلا كده.
يطلع 0.583.
0.583 seconds. Now substitute this in this equation, guys. So this becomes 0.583 minus the time in steel equals 0.544. So the time in steel is equivalent to
0.039.
0.039 seconds. Okay, fine. Is that clear? Now I got the time in steel, so substitute this here. I will get around 5,000 something, صح? 100.
5,230.
30. Okay, guys. It's a little bit tricky question, so we have to consider it. If you have any question, please ask me. Okay, great. This is another question for me, similar to the previous idea. During thunderstorm, thunder and lightning are produced at the same time. A person is some distance away from the storm. Explain why the person sees a lightning before hearing thunder. شو رأيكم تجاوبوا هذا وتعطوني الانسر تاعتكم؟ مين ده جاوبنا اياه هلا؟ زينة؟ لا كثير هيك اليوم زينة نشيطة. زينة يلا. زينة.
أستاذ أنا ما حكيتش إشي.
رفعت ايدك، كيف ما حكيت إشي؟
لا والله.
أنا شايفك.
عن جد شايف أستاذ، ما بصير.
أكيد مش شايفك، بس يعني قصدي إنه
الحمد لله.
بإحساسي.
أستاذ ما تحس إني لساتني عم بحاول أفهم يعني مش ما حرف
Light faster.
اقرأي لنا السؤال زينب.
Okay, during a thunderstorm, thunder and lightning are produced at the same time. A person is some distance away from the storm. Explain why the person sees the lightning before hearing the thunder. عشان light أسرع.
Definitely. بس شايفة؟ Here the light
أنا ملكة الفيزيكس.
طبعا أكيد travels faster than sound. اوكي طيب سند؟ لا كثير هيك سند يعني مش قادر. بدك تشارك معنا؟ يلا سند المايك معك حبيبي. اعمل انميوت بليز.
أي سؤال أجاوب؟
The second one يلا.
توري. بتكون 4 seconds.
Yes. How did you do ايش؟ يعني how did you deduce that?
لأنه it's the least time in between seeing lightning and thunder.
Perfect. It's the least time. So definitely will ايش? This is ايش? We will continue talking about what? Waves. Okay. If you have any question, just ask me. Okay, guys. In the previous time, let me very quick revise with you the refraction. Like guys, the second behavior or the second behavior of the waves when they meet a boundary is the refraction. The refraction is taking place if the waves enter from one medium to another. Okay, from one medium ash to another. So there's a change in direction, right? It may change its direction depending upon the angle of incidence. Please يعني pay attention for the screen please guys because of the change in speed. هلا عندنا incident، هذا incident ray تمام، وهذا refracted ray. طبعا ال refracted ray, or if the light is coming from denser medium to less dense medium, from denser to less dense, the refracted ray bends away from the normal. Bends away from what? From the normal. The frequency stays the same, the speed increases with wavelength increases. The second case, guys, the second case, if the waves or ray enter from rare medium or less dense medium to denser medium, like this case. The ray bends towards the normal. Let me explain this for you guys. Regularly you'll be asked about that. You have to draw the refracted ray. طبعا here the refracted ray حكينا bends towards the normal. Bends towards what? The normal. ترى كيف بعمل عشان أشوف how it will bend towards the normal. بحط الرولر in the direction of the incident ray. شايفين ال incident ray هاي الرولر. Bends the ruler towards the normal. شايفين أنا كيف عملت؟ Then draw the line. Then draw what? The line. This is what? This is refracted.
كيف نعرف إنه كم الأنجل؟
أيوة هلا بنشوف كيف نعمل في الأنجل. هلا sometimes you are asked to draw it without an angle. So just you have to show the examiner that the ray bends towards the normal. If you are given the angle, you have to use the given angle. Okay. This part we talk about refracted waves. Here, guys, in this part, we will learn how to draw. Listen, pay attention, please, guys. In this part, we will learn how to draw the refracted waves, not the refracted rays. Refracted waves. Here, guys, we have here waves, incident waves. These lines شايفينهم الريد لاينز هدول؟ ايوه هدول الريد لاينز. These red lines are called incident waves or wave fronts. Wave fronts. Now, these waves meet a boundary here. This boundary, guys, between deep water and shallow water, right? This boundary between deep water and shallow water. In shallow water, guys, the water waves move slowly. Okay, water waves move slowly, no matter why. No need to know this, but we have to know in water.
Which is forces and energy. Now, energy is a really important part.
Sorry. The water waves move what? Slowly. Water waves move slowly in a shallow water. طيب, what does this mean? How can we will draw now the refracted waves? طبعا definitely the speed here will be different than here, and the speed in shallow water different than the speed where in deep water. As a result of that, اسمعوا شو بحكي. As a result of that, guys, the waves or the wavelength and the speed will change. Now, how we will draw these waves? Look here, please, guys. If the waves are traveling from medium, where the waves that have higher speed, to the medium that the waves have lower speed, the waves bend towards the boundary. Not the normal, guys. Here we are not drawing a normal. Here الwaves bend towards the boundary. طلعوا كيف راح ارسم الwaves هلا. هاي الويف bend towards the boundary. هيها. طلع كيف حركت الرولر. هاي. I place the ruler in the same direction of the wave. Then this wave bend towards what? The boundary, like this. This is the first wave. This is the second wave. They should be parallel. Okay, guys. These waves must be parallel and closer. Okay. And what? To locate the image of the object. But here we have to use what? The refraction, not the reflection. Okay, refraction, not the reflection. If I have an object like this, let's say this is a water surface. Okay, let's say here we may have an object, this position. This is object, and we want to locate the possible position for the image. The possible position for what? For the image. What I have to do, you know this. The possible image it should be somewhere here. Okay, this is the possible what? Let me select dot, much better, and this is the object. Okay, so the possible location for the image from this from our knowledge will be somewhere here above, right? Somewhere here. This is what? The image. Now, how we will use the ray tracing in order to locate this image? If you remember, what did we do in the previous time? Look here. Now we will take two rays from the object. Two rays. Our first ray. Okay, I may take another ray like this. These are two incident rays. Okay, then the next step, I have to draw a normal to the surface. This is a normal. I will draw it using a pencil. This is a normal. Okay. Now I have to draw the refracted rays. طلعوا كيف بدي ارسم الرefracted rays from the image. Guys, والله انتبهوا معي هون. طلعوا refracted ray from where? طلعوا على الرولر تاعتي. Look to the position of my ruler. It seems I will draw the refracted ray from the image. So I can extend it like this. The other refracted ray also starting from the image. And I will extend it like this. Okay? So these are called refracted rays. I extended the refracted rays to locate the image. So again, let me make a summary for what I did. First of all, I draw the possible position for the image. It should be above the object. Okay. Then draw two rays from the object at different positions. High position, high position تاني, صح? Then draw a normal. After that, draw the refracted ray using a ruler, starting from the possible position of the image, like what I did now, right? This is the first refracted ray from the image. This is the second refracted ray from where? From the image. In this way, you can locate the image, and you will be asked to do this also in the past paper questions. Any question about that? Okay. Another application, guys, that we have to know how to do it. It's the refracted ray of multicolors, or which is called dispersion of light through a glass prism. All of you, from your previous knowledge, knew that if there is if there is a ray of white light enter a prism, we will have what? We will observe what? Spectrum, right? Or the colors. Okay. Here we will be asked to draw this. All of the, look here, guys, from less dense, this is less dense, to what? Denser. Again, pay attention, guys, pay attention. خليكم معي. From less dense medium to denser medium, all the light rays bend towards what? The normal. Bend towards what? The normal. Is that clear? Okay, guys. Now, so all the colors, like what did you see here? All the colors are bending towards what? The normal. Are bending towards the normal. Here in this region, okay, in this region, the light rays or the light colors are bending away from the normal, right? Are bending away from the normal. The point here, the blue bends best. Okay, the blue is bending what best, or the violet bends best. Okay. Now let me show you how we will draw this. طلعوا معي please, guys. This is the white light. Okay, this is the white light. Here we are seeing the colors. طيب, let me show you this here. Here we have white light, boundary between air and denser medium. Regularly, you will be asked about drawing two colors only, red and violet, right? Red and violet. As what you mentioned before, violet bends best. Violet bends best. Here, both red and violet bend towards the normal. Why? Because the light is coming from air to denser medium. Okay, from air to denser medium. But the violet bends best. ركزوا معي على هاي. كيف يعني؟ يعني إذا if I want to draw violet, طلع معي هاي, both of them will bend. طلعوا على حركة الرولر please. Guys, notice the movement of the ruler or the bending of the ruler. هاي. I bend the ruler towards the normal. This is the red. Okay. And this is what? The violet. طبعا don't forget to add arrows. This is red. This is what? Violet. Guys, again, both red and violet bend towards the normal, but the violet bends what? Best. Clear? Okay. Let me show you a question from the past paper. Here, white light incident at P on a glass prism, only the refracted red ray PQ is shown on the prism. On figure 6.1, draw a ray to complete the path of the red ray and the whole path of the violet ray up to the point where they hit the screen. This is the screen. Guys, pay attention, please. First of all, any drawing, any ray tracing, we have to draw a normal. طلعوا بالله معي على النورمال. How will I draw it? فرجوا بالله معي. Look to the position of the ruler, guys. I place the ruler in this way. So one of the lines على الرولر, شايفينهم اللاينز اللي على الرولر دول اللي هم divisions on the ruler, coincide مع الباوندري. Okay. Now I can draw what? A normal. This is a normal. It's the easiest way, guys, to draw a normal. To make one of the lines on the ruler coincide مع اللاين تاع الباوندري. الباوندري. Okay, this is a normal. And this is incident ray. This is white ray. طلع معي كيف. In order to prevent any mistake of drawing, because you will be asked to do this. Guys, this is the initial position or the position of the incident ray. طلعوا كيف على الرولر جماعة. كتير مهم هذا التكنيك. هاي الرولر. I place the ruler in the direction of the incident ray. هلا both of them, either violet or red, will bend towards the normal. فرجوا كيف I will bend the ruler towards the normal. Let's say this is red. This is what? Red. Okay, clear. الviolet will bend more. طلعوا كيف حركت الرولر towards what? the Is that clear, guys? Here again, I have to draw two normals because I have 2 points of incidence here. Another normal here. Guys, I'm showing you everything in detail. Okay, now الريد هلا both طلعوا ما عند هذا الباوندري. ركزوا بالله, pay attention guys, pay attention. Guys, at this boundary both rays will bend away. ليه؟ لأنهم they are going from denser. طلعوا عند هذا الباوندري guys, عند هذا الباوندري light are coming from denser to less dense here. Here what? Less dense عند هذا الباوندري. So both, pay attention, both will bend away from the normal. Both will bend away from the normal. But violet bends best. Violet bends best. فطلعوا على هاي الانسيدنت راي عند هذا البوينت, شايفينها؟ هاي اللي هي البوينت اوف انسيدنس. هيها. هلا صار عندي 2 points of incidence here. هاي بوينت وهاي بوينت. هون هاي الانسيدنت راي عند هذا الباوندري. هلا bend away from the normal. طلع كيف راح اعمل bends away. هاي هيك راح احرك الرولر away from the normal. This is when the ray bends away from the normal. Again, for violet, also it bends away, but it bends more. It bends more. Guys, please notice now the movement, the rotation of the ruler or the movement of the ruler. Look, it bends what? More away from the normal. This is violet. And this is what? Red. Okay. Now let's talk about calculation. The previous part was graphically. Okay, يعني it was about graphical representation of what? Of the refraction. Okay, graphical representation of the refraction. Okay. Now, what is Snell's law? No need to know these things, but يعني just for your information. هلا, I want to make a calculation. Now, we have to make what? Calculation. The previous part was just a drawing. To make a calculation, we have something called a refractive index or optical density. Okay guys, refractive index or optical density. This refractive index will show you density of the medium relative to the light. How can we find the refractive index? We will divide the speed of light in air over the speed of light what in this medium. This refractive index, guys, equals sine I over sine I. I will explain this for you. Or sine R over sine I. What is meant by I and R? Look here, please. I is the angle of incidence, R is the angle of refraction. Angle of incidence, it's the angle between normal and incident ray. Angle of refraction, it's the angle between normal and refracted ray. Okay? So, when can I use this, guys? When can I use this? I can use this if the light travels from denser, from less dense medium to denser. Here I can use it if the light travels from denser medium to less dense. Okay, guys, I have now 3 formulas here. This is the first one. This is the second one for refractive index. This is the definition of refractive index, guys. This is what? The definition. Okay. Let me show you this. طلع معي هذا question من past papers. Figure 6.2 shows another ray passing through a same glass block. We are given here the speed of light between W and Q, the speed of light between what? Q and Y. Here in air, here in what? In glass. Okay. What we are asked to do there, we are asked to find the speed of light where between Y and Z. And this is air also. It will be similar to 3 times 10 to the power 8 meters per second. Because guys, from W to Q, ركزوا معي. Pay attention guys, all of you please. From W to Q, air, or from W to Z is air, so the speed will be the same. Now write down an expression in terms of speeds of light that may be used to find the refractive index of a glass, define the value of refractive ايش او determine the value of refractive index. هلا here the refractive index اللي اتفقنا هي n صح؟ هي n equals speed of light in air. Guys, when I finish this question, I will finish the class. Over speed of light in a glass. So we can find this, n equals 3 times 10 to the power 8 speed of light in air over speed of light in a glass, which is 2 times 10 to the power 8. This will be 1.5. Explain why there is no change in the direction of ray PQ as it passes out the glass. بالله ركزوا معي the glass. Sorry. Pay attention for this guys, please. هلا طلعوا هون. Pay attention guys, please. Look here, please. Here, this is an incident ray, W to Q. Did you see it? This is from W where to Q. The light ray bends towards the normal, but at point Y, the light ray continues at the same, in the same direction. It's not bending. Why it's not bending? Because guys, it lies on the normal. And if I draw a normal here, look to the normal that I've drawn now. If I draw a normal at point Y, ركزوا معي. If I draw a normal at point Y, the incident ray here lies where? On the normal at point Y. If it lies at the normal at point Y, معناته it will not bend. Clear? It will not bend. Any question about that, guys?
بظبط نحكي الانجل زيرو.
Yes, the angle is zero, definitely. The angle is zero, or it lies on the normal, or it's incident normally. طبعا الويف لينث ايش راح يصير فيه؟ طبعا راح يصير فيه increase. ليه؟ لانه من جلاس لإير from glass to air. ركزوا بالله pay attention. From glass to air the speed increases, right? So the wavelength what increases as well. Any question guys? طيب any comment about the class online? My sound, was it clear? السكرين الاكسبلانيشن
كله تمام.
طيب يا رب جماعة مرة ثانية بأكد عليكم قرأت لها فرح هلا إن شاء الله. Guys anything you need it أنا موجود معكم أونلاين بس inform me قولوا لي مثلا أستاذ إحنا we need another class بدنا نسألك شوية أسئلة anyone حتى no need for the whole class يعني بنعمل meeting وبنقعد anyone would like to attend the class no problem. Okay don't hesitate guys to contact me. اللي طلعوا مين هم؟ فرح بس فرح طلعت كانوا من فرح
واحد
كنان شهد سند زينة اوكي ماشي. طيب guys يلا have a nice day واذا بدكم اي شيء please contact me. اوكي
تمام شكرا أستاذ.
يعطيكم العافية. هلا راح يكون ريكوردد وبننزله على البيج اللي ما حضروا بليز يحضروا.
تمام
يعطيكم العافية.